All right, everybody, we are in for a treat today. We got a lesson on related rates. So let's jump right in. We've got an area formula up here, area of a circle, and I've given us some information about both the radius of that circle at a given time and the rate of change of the area of the circle being 16. I didn't put units on it for this one. And so we're looking for the rate of change of the radius at this given time. And so to do this, we're going to take a derivative here using implicit differentiation. The derivative of a we just call dA dt. And then we've got a power rule over here. Pi is a constant, so we just leave it because it's being multiplied. And we take the derivative of r squared, just like x squared, giving us 2r to the first. But the big difference here is because it's with respect to time, we multiply by dr dt. Now, once we have our derivative, we're looking to solve this for dr dt, and so we're going to just plug in the other values. So plug in 16 for the derivative of a, and then plug in 2 for r. All right, so this gives us 4 pi. If we divide that over, we're going to get that dr dt, derivative of r, is equal to 16 over 4 pi. Which we could also simplify the 16 over 4 and make it a 4 over pi. Now this one wasn't too bad, it was just the power rule. But keep in mind, as you're doing these derivatives, we might have a product rule, there might be a quotient rule, there might be a chain rule, it might be memorized. Okay, it's not always just power rule with these. All right, so instead of looking at an example, you guys have already learned how to do this. I want to just remind you of step by step, if you're given a word problem, how do we go through these questions here? All right, well, the first step is always going to be to write down a formula. Sometimes it's going to be given, and you know it's already written down for you. But a lot of times you have to use context clues to figure out what formula we're using here. Is it a Pythagorean theorem question? All right. Do you have to set up a trig equation here because we're talking about the angle of a triangle, right? So maybe not cosine, maybe it's tangent, maybe it's sine, right? But one of our trig functions. We just talked about the area of a circle. It could also be the area of a right triangle here. And so it really just depends. Do they give you a formula or do they reference a certain shape that you are going to need to know the formula for? All right, but that's our first step. The second step is to write down all of our known variables. So maybe in a question they just tell us that the height or the depth is 10 meters, right? So we just write that down. They wouldn't write this in notation, but I'm going to talk about how this would be phrased in a question. So it might say something like the depth of the water is decreasing at a constant rate of 2 meters per second, right? So if it says decreasing, that's where the negative comes from. But for it to be a derivative, it's going to say the rate of change here. Okay, and so this is going to talk about the depth or the height. This is going to talk about the rate of change of the depth decreasing at that rate. All right, the third step then would be to solve for any missing variables, if there are any, but before we actually take a derivative. So for example, if it's a Pythagorean theorem question, you might be given a and c. You might be told, hey, a is 3 and c is 5. And you've got to use this equation to solve for b, or recognize in this case it would be a 3, 4, 5. But you might have to do that before you take a derivative, solve for one of the missing variables. All right, once you've done that, you would actually take a derivative using one of the rules that we talked about, and then solve for whatever the question is asking you to solve for. All right? Now, 2 quick reminders. Some problems that we worked out before. We've talked about a cylinder. Keep in mind with a cylinder, the radius never changes, right? No matter where you are in the cylinder. So its rate of change, the rate of change of the radius is always going to equal 0 for a cylinder. Now for a cone, there's going to be a way that we can relate the radius and the height of the cone. All right, I'll give you some more concrete numbers in a second. But what we have to do is before we take a derivative, we're going to either have to eliminate the radius or the height from the equation. All right, so let's say, for example, that the radius here is 2. Okay, we're told the radius is 2, and maybe the height is going to equal 10. Well, if that's the case, there's two equations I could write. I could write that the height divided by 5 gives us the radius. Or I could write that the height is equal to the radius times 5. All right, so this is the equation I would write if I wanted to get rid of r. And this is the equation I would write if I wanted to get rid of h. Well, how do I know which one to get rid of? Well, in the question, they're either going to give you the rate of change of the radius, or they're going to give you the rate of change of the height. Well, if they give us the rate of change of the radius, I would want to get rid of h, right? I would want to use this one to get rid of h because I don't know the rate of change of the height. Or vice versa, if they gave us dh dt, I would want to get rid of r because I don't know dr dt in that case. All right, and so if you're given a cone question, we are going to have to eliminate one of the variables and simplify before you take a derivative. All right, so that should give you guys just a quick reminder of how to do these questions. We will, after you guys do your practice, we'll go over these problems on Monday, but you guys should be good to go with those problems now. All right, as always, stay flawless.